Sensor components are transducers that change non-electrical signals into electrical signals. In this lesson video, I'm going to cover one of those types, the piezoelectric crystal. Now, I think piezoelectricity is pretty neat. It is the ability of some materials, including crystals, ceramics and bone, to produce an electric potential when mechanically stressed. Try putting that into your own words. I'll give you a moment. It's going to produce an electric potential when mechanically stressed. So basically, stretching or squashing it produces electricity. It's reversible too, which means that if we apply a potential difference across the material, it will be stretched or compressed. It's like a motor or generator, but without magnets, made of bone. Anyway, it's got lots of uses, including mass balances, motors, lighters, speakers and microphones, but I'm going to let you look into those yourself. What we're going to look into is how it works. So I'm going to take a crystal like quartz, silicon dioxide. It's got positive silicon and negative oxygen atoms in it. By the way, apologies to chemists, I'm going to keep this at a level physicists will find useful. In fact, actually, let's go even more extreme and simply consider a structure like this that has 3 positive atoms and 3 negative atoms. It will demonstrate the principle just fine and is a simplified version of what happens in the quartz. The center of positive charge is here, and the center of negative charge is also here. Okay, they're lined up. But what I'm going to do now is I'm going to squash it. So let's squash it. Okay, see what happens? Okay, with the charges, the top looks more positive now, and the bottom looks more negative. If we consider the centers of the charges, we can see that they have separated. What does that mean? Well, that means we've got a potential difference. Now, what happens when we stretch the crystal? Look at the charge again. It now looks more positive at the bottom. And looking at the charge separation, it has been reversed from before. This means that if we repeatedly squash and stretch the crystal, we get an alternating potential difference. We get AC electricity. If we instead applied an alternating potential difference to the crystal, the positive and negative centers would be attracted and the crystal would squash and stretch. As it does so, it will make pressure changes in the air, which is sound. Very quiet maybe, but it's something we can build on. So that's the piezoelectric transducer, a device that converts between electrical and strain energy, and it does so in a wide range of applications. You're actually going to come across this again when you look at ultrasound, so it's well worth making sure you understand the science behind it.